Thank you everyone for attending today's technical demonstration session on Gravitee. I'll give a brief introduction and then pass it over to our speakers. So please feel free to ask your questions at any time by writing them into the chat. We will ask them to the speaker during the session or at the end of the session. So to begin, I'd like to mention that in the most recent Gartner Magic Quadrant for API management tool, Gravitee is recognized as a visionary and new entrant for 2023. Yeah, and it is a robust and comprehensive API management platform and has some, I think, unique capabilities. Some of them our speakers cover. Yeah, and today our guest speakers are from Gravitee, Charlie and Ilish, sorry. I will discuss the current trends in API management, such as event-driven architecture, Kafka Gateway, and multi-gateway management. We aim to minimize the use of the slides in the session and focus on more practical demonstration and discussions. Yeah, and now I'll hand it over to Charlie and the team.
Cool. Thank you very much, Stanislav, and really good to meet with you all today. And Ilesh and I are very much looking forward to showing you around some of the challenges that we see a lot of businesses experience, particularly around governing and exposing asynchronous APIs and also federation. So what I'll do is I'll take a very short amount of time to almost set this up and give you an understanding of these challenges and a little bit more detail, and then I'll hand straight over to Ilesh, who is one of our lead solutions engineers. I work on the sales team, and he'll be able to give you a closer look into the platform as well from a more technical standpoint. So I hope that's okay with everybody. Stanislav, is my screen viewable to everybody?
Yeah.
Yeah. Okay. Cool. See. So good stuff. So what I'll do, I'll just kick this off. If my screen would work. So the first challenge is API management for asynchronous APIs. Now, looking back previously, what we found is like lots of businesses obviously have an API gateway or have some sort of way to manage their APIs. Some don't, but I would say that most of them do. And legacy API management, as we refer to it, is something that has been great in the past, but it's a very fast moving and very sort of it's an evolving space, if you like. And this screen kind of represents what we had, what we currently have with a lot of vendors that are on the market right now. A place where you can proxy your backend and expose almost traditional APIs over, REST APIs, SOAP APIs, for example, as REST or gRPC, for example. And with those APIs, you have an element of control and governance to them, right? So any rate limiting or logging or authentication and authorization, for example. And that's really helped us solve a lot of problems with regards to kind of reducing that sort of spaghetti integration that all of us, I imagine, on this call have experienced or at least seen at one point or another. But what happens if you want to take that step further and you want to expose more than just REST? With the further adoption of event-driven architecture or EDA these days, unfortunately, a lot of the gateways on the market at the moment aren't suitable and aren't able to or aren't compatible with sort of more modern technology. So if you're a business that, I mean, see most businesses, I'd say, using perhaps Kafka or some sort of flavor of Kafka, like Confluent, for example. Some might be using some MQTT or RabbitMQ or Solace or any of these event brokers, collecting real-time data that they want to expose, not just internally, so that teams have that real-time data available to them, but also externally as well to their customers. And they need to make sure that that data is easily consumable. So they might want to expose that, a Kafka API, for example, over, WebSockets or webhooks or SSE, or at least want that flexibility to be able to expose what you want as you want. And that's really where Gravitee comes in. So, you know, we're a full lifecycle API management platform, but we firmly believe that, you know, event-driven APIs should be treated as first-class citizens. So Gravitee doesn't necessarily care about what the back end of your API looks like, whether it's a REST API or a SOAP API, or a Kafka or a Solace or RabbitMQ API. And we don't really mind what you want to expose it as either. If it's you know, HTTP or WebSockets or webhooks, it should be down to you as an engineer or as a business. But then importantly, there needs to be that sort of middle layer of management of those APIs. So in the same way that you would manage a synchronous API or REST API, for example, and you'd apply security and policies to those APIs, we feel that asynchronous APIs should be treated as first-class citizens. And you know, that connection, so we're event native, is important, but also you should be able to govern and manage those APIs, those asynchronous APIs, to a high level as well. So we're going to show you a little bit about that today, and I think we're going to focus on a Kafka API as an example. Now, the second problem that we see emerging in the market at the moment is businesses using a multi-gateway architecture. We hear about it and we see it all the time now. Businesses do have API gateways, but they use a mixture. They might use some Microsoft or, you know, some AWS or, you know, APIs. Some of them are hosted on Apigee, for example, and that surfaces another problem in itself, because they already have you know, something to proxy their backend. They already have you know, elements of security applied to their APIs and some kind of discoverability. But that API fragmentation brings a new problem. It harms the developer experience. If I'm an engineer, I don't know if I should find my API on this gateway or on that gateway, for example. It raises problems with API design and consistency of security. You know, are all of our APIs secured in the same way? And a lot of businesses seek you know, a way to standardize this and effectively a single pane of glass for all of their APIs. And that is something that we call API Federation, is something that we released earlier on this year. So I spoke earlier about one platform and one solution for asynchronous and for synchronous and asynchronous APIs. But now we're one platform for synchronous, asynchronous, but also third-party APIs that are hosted on other gateways as well. So this slide kind of really sums it up. Down the bottom here, you can see the technologies that Gravitee would typically work with: REST APIs, Kafka, MQTT, Solace, also APIs from other third-party gateways. The middle layer there is that management layer. So, you know, any rate limiting or security policies that you want to apply to those, any analytics that you want to pull from those APIs, and then all of that can be exposed in one universal developer portal with automated documentation for true self-service API management. So with that, I'm going to hand over to Ilesh now, and he's going to show you around the platform. And obviously, if you have questions, feel free to put it in the chat box and let us know. Ilesh.
Yeah, okay. I'll just share my screen very quickly. Cool. So you should be able to see my screen now.
Yes,
so
we can.
What I'll do is that I'm gonna concentrate on exactly what Charlie talked about in terms of Kafka, but just wanted to kind of quickly play through all the products. So Gravitee is not just an API management tool. Essentially, what you've got is that you've got kind of a whole platform, something that allows you to manage your environment and see exactly what's happening in your API landscape, something that allows you to design APIs as well, right? And then once you design them, you can actually auto document them and then push them into our API manager. So when you think of Gravitee, do think of that whole stack. So we've got design, we've got management, we've got API management, and we've got access management as well. So a whole stack of tools, and all of these tools contribute to what Charlie's talking about in terms of being able to do everything in one platform without having to move outside it. So, in terms of this demo that we're going to talk about today, it's very much about Kafka, right? So very much about event sources, etc. So we've actually got a great little demo that we've got here, and I'll talk it through together. So imagine there's three scenarios, and I think Charlie's kind of covered quite a lot of them here. You've got an ability. So say for example, you've got an ability to talk to. You've got an event source in your company, right? And you've got a traditional backend service, like Spring Boot applications, and you've got some kind of way. You want some kind of way of bringing them all together, such that somebody can consume that data in a standard way. That is protocol mediation, right? If you want to expose even backend sources in a standard way, that's protocol mediation. If you want to now, if you've got an organization, and we see them all the time, that have got loads of different gateways, they've got some AsyncAPI, they've got some Gravitee, they've got some confluent topics. So imagine one place that you can actually go to in terms of a developer portal, which can bring all of that, expose all of that data in one single place, and somebody can kind of subscribe to it. They can access it if they've got the right access, or they can request access. So don't think of APIs now. Think of actually Confluent Cloud topics as well, or Solace topics, and you can federate them into Gravitee, and you can see them in a single pane of glass. And the middle one is actually the newest one that we've got. So what we've got here is that protocol mediation essentially breaks the protocol. So you've got Kafka on the back end, and you've got an API management tool. And what actually happens is that you basically say, okay, in front of Kafka, I want to put a REST API, right? Now that kind of can work, but also a lot of our customers are asking about direct Kafka. So basically proxying Kafka, Kafka proxying Kafka, right? And that's where the Kafka Gateway comes into play. And I'll show you a demo of the Kafka Gateway in a second as well. But essentially, you can talk to native Kafka and then put in things like rate limiting, quotas, topic routing, even message transformations. So you can almost treat it like an API is traditionally treated. You can document it, you can subscribe to it, but actually there's no kind of concept of talking to it via REST. You're talking to it in native Kafka, right? So you can actually manage your applications. And I've just done a demo of this where, we were talking about integrating the Confluent schema registry, and how Gravitee can allow you to do that, and also check what the producer is sending, such that you can be a gateway to make sure that you don't get any messages that are not conforming to that schema in your brokers, essentially, as well. So you've got, like what we've done, and this is just our Kafka event source offering, is that we've tried to cover all three bases with our offering on event-driven architecture. Okay, so if we now go through, we'll just quickly go through. You can see I've got a great slide here which I showed earlier. Let me just see if I can get that open. So here's the demo that I did for another organization earlier. And essentially what we've got is everybody here that's used Confluent Cloud knows that you're limited in your ability to authenticate into Confluent Cloud. But what you can do with the Gravitee Gateway is that your client can authenticate using SASL or OAuth. So you can, you can authenticate using whichever mechanism you want. That will give you access to the gateway, and the gateway is now using the traditional method of authenticating with Confluent Cloud, which is SASL plain. So basically what is actually happening here, so he's got Kafka to Kafka. On the face of it, you're authenticating in the mechanism you want. Gravity's mediating that authentication to actual Confluent Cloud. Okay, and in the middle, what you can also do is that you can actually do things like topic filtering as well. So you've got this full flow of actually having Kafka proxying Kafka with the ability to add business logic units like topic filtering. Um, you know, um, you can even add conditions on claims so that you can make sure that the authentication is as you need, depending on the access token you're bringing in as well. Okay, so essentially that's it. So I'll stop there because I think that you guys will have questions, because this is part of this is a big part of what Gravitee are bringing to the table now, especially when we're talking about event sources. So if you've got any questions, it would be great to make sure that I've explained that properly.
So far it seems all clear.
Okay. Okay, so one thing that's worth showing you about this is that you kind of go through the authentication flow. So you configure your local server. You now add a authentication to essentially talk to Kafka. So you do this in the normal way. You can add a plan here. You add an OAuth2 plan. Okay, so you add access control. And now what actually happens is that you've got your architecture for what you're doing. So if you remember our demo, we were going client to OAuth to SASL. And you can see that's replicated here. You've got SASL to the backend service. So that's my gateway. It's actually the other way around, but that's gateway to Kafka, SASL, but OAuth here as well. So you've got kind of OAuth, the client coming in, hitting the backend service, talking in the right way. Now that's the authentication piece. It's not, it's basically good to have, right? But now look at this. This is the ability to add policies into that flow as well. So you've got the ability to add policies in. If you've used Gravitee before, you'll recognize the screen, but this is on the connection phase. So I can now go back and add policies. So the policy that I'm going to add first, I believe, is topic mapping. So if I go to here, one of the big use cases that we get, and Charlie and I have heard this a couple of times, is that a customer's got a big Kafka topic. It's basically got a lot of information coming from a lot of places. But when they want to expose that topic to their customers, they don't want to expose the big topic. They want to have like a proxy topic, essentially. I think that the official name is virtual topic. So you can actually say, customer one, this is your topic. It actually feeds into a bigger topic or another topic. But when you expose the topic, you can expose the name that you want. And that's super important for like making, especially when you're publishing this on the developer portal, you can actually have a topic mapping, and that's particularly useful when you're exposing data to customers. Okay, so what we've got here is we've got the input topic, and we're upstream topic is dogs here. Okay, so now what we're going to do is, I think we're going to another flow. So here we're doing the policies for the publish phase. Now, if you've ever done any work with Kafka, then you'll know that those messages can come in a number of formats. So you've got Avro, you've got protobuf, and you've got direct JSON as well. So what you can do on the message phase is that you can actually add your connections to schema registry directly here as well. So you can make sure that your data's conforming to the schema that's expected in your target Kafka cluster. Super neat, in terms of what you can do there. This is the rate limiting policy. And what you can see here, it's just a simple configuration. You can just add in the time duration, add in the number of requests, and you're able to rate limit. So rate limiting of Kafka is super. It's actually a kind of a slight confusing topic. When I first heard about rate limiting from Kafka, I found that that's maybe non-intuitive. But what we found for our customers is that if you've got lots of data which is valuable and you want to monetize that data, so say for example, You've got like data analytics on how a player is performing in a basketball league. Then if I can rate limit that data to say you can get the health statistics every minute, but not more than that. Or if you want to go for every 30 seconds, then you want to increase your monetization price and you can get the data that way. So rate limiting on Kafka cluster is actually a great way of locking down how much data people are consuming such that you can monetize that data.
So
Okay, so what
maybe
we've got.
sorry, one question regarding rate limit. Okay, it's really cool. And is it? Do we have, how to say, some capabilities like levels? For example, client one can send 10 message per second or per time. Yeah, another client can have 1 million, something like that.
Yeah, that's it. That's exactly right. So let me actually just show you directly here. I want to answer the question properly. So I'm just gonna let me just do it on a normal proxy. You'll just still see it from here. I just want to make sure I answer that question properly. So we've got a kind of a normal REST API here. Now, if we go save and deploy here, you've got the concept of policies. So I've got a particular flow, so I can do keyless flow here. Okay, so that's my keyless flow, and I can add rate limiting here. I'm going to say one maximum request once. Actually, let's make that 10. Once every 10 seconds, they're allowed data. Okay, so I'm essentially proxying that way. Okay, now I want to add so that's a keyless consumer. So say, for example, now I want to add another type of consumer. So this time, let's add an API key plan. And remember, you can have as many of these customers as you want. You can have customer 1 plan, customer 2 plan, customer 3 plan. So let's do customer 1 plan. Yeah, and do next, and do next, and do next. Okay, so this is an API key plan. But because it's an API key, you've locked down that API. You can see here, you've got another flow. So on this flow, I'm going to say, well, they've authenticated, so they must know us. So let's add they can ask for data once every 3 seconds. Okay? And in that same way, what you can do is actually have multiple flows for different customers. Now, what you may also say, well, actually, Elish, that doesn't maybe that doesn't make sense because we want to actually only have one way of authenticating. But if Charlie logs on, he's a friend. You want him to have as many data as a really good rate limit. Well, you don't know me, so you have a reduced rate limit. Well, you can do that because what you can do is have this concept of conditional flows. So I can say, apply this rate limit, if I just crack that open, on a trigger condition. So that trigger condition is, oh, Charlie's authenticated from the Gravitee source domain. So because it's, and you can put your expression language here to say, if the request value is this, then activate this rate limit policy. And then you can add another rate limit policy, and that's only triggered if it's me. So you can actually answer your question in a number of ways. Like you can kind of lock down for one customer, and not lock down for another. But Gravity's got a number of ways that you can essentially create that like case statement. It's like it's basically in code. It's a case statement where customer 1 does this, customer 2, blah blah blah, and you can bring in that logic that way. Does that make sense?
Yes. Yes, but we have another question, and
Yeah, sure.
it is how is high availability handled for a Gravitee gateway proxy in Kafka, and does that have any impact on rate limiting capability?
Yeah, so high availability. So essentially, what Gravitee is running on is a cluster, right? So like our customers normally go for it, and our gateways are essentially able to handle a good size gateway is able to handle about 40,000 transactions per second. Just as a normal cloud gateway that we offer, it's that kind of level of transactions per second. Now, if you double it for high availability, so you've got two Gravitee gateways sitting alongside each other and an active state, then you can understand what kind of transactions per second you're able to consume with that Gravitee gateway. Now, if you're now thinking about so we've got a customer that wants 600,000 transactions per second. So we did a vertical scaling and a horizontal scaling on that. So increase the size of machines, and we had more machines as well. So essentially, what I'm trying to say in answering the question is that Gravitee can basically scale up or out to conform to that to the requirements, but also in terms of rate limiting, it's not adding latent. Is the question about adding latency to the API calls, or what was your question really about?
Stanislav, I can answer if that's okay. Right, yeah, I wanted to understand if you're scaling out horizontally, how the level of accuracy that you can maintain on measuring the rate limiting to a particular client across different nodes.
Okay, so essentially, when you establish a connection to a Kafka cluster, and that can, as soon as that connection is established, it's talking to a consumer group. So in terms of Kafka, it's talking to a consumer group. So essentially, what you're doing is that you're establishing a connection and you're holding an offset for that position. So I've got the data, I've grabbed it, I've managed my offset. Now, if you've got high availability, it's still talking to the same consumer group because it's the same API. Every API has a one-to-one relationship with the consumer group that's grabbing the data. So it knows about the offset. So it will continue to grab data from the offset that's been updated. And that's how to manage high availability, because if it's the same API, then it's using the same consumer group in Kafka.
Okay, so I thought maybe I misunderstood them, because I thought you were talking about rate limiting on the publishers as well. Is that so? Did I misunderstand that?
Yeah, rate limit on publishing. That's an interesting one. So can you tell me the use case there? Rate limiting on publishing is available, but yeah. I just want to understand the use case before I answer it.
Yeah, no, that's fine. It's well, I guess it's throttling back because you want to protect the resources that are downstream. So if you know that you don't want to accept more messages than you can consume, you're pushing back on the subscriber. So typically in the messaging space, you'd have kind of like pushback to prevent you flooding your broker infrastructure with more messages than it can store at certain points. So it's that type of use case I was thinking.
Yeah.
But it may not make sense for Kafka, so that's fine. That's perfectly fine.
Yeah, I mean, that's my concern. It's like if we start throwing away messages or not accepting messages, I mean, essentially, our back end is a log, and like the Kafka is a log. So essentially, if you're rejecting messages, then those messages will essentially come through later anyway, because you just get an ACK back to your publisher, so they won't be accepted. So you could send it later, but that would be an architectural conversation rather than that. So our rate limiting publishing wise, in the customers that we've talked to so far, they don't want any rate limiting on publishing because they want to accept everything, and even to the extent where they want to understand if we ever drop a message. They want to have the kind of the native Kafka errors that are propagated from Kafka when messages are potentially not acknowledged, essentially. So you can have rate limiting coming in, but I'm not sure of the use case on that one, to be fair.
Yeah, I don't want to derail the session. I guess the only other thing I would be thinking about is if you're opening up your Kafka topics to more consumers, you don't want one of your consumers to go rogue and basically end up, flooding you with spam. So maybe there is there's a use case there again for kind of having a top end limit. So
I've got an example. Oh yeah, definitely. That's totally right. So that on the consumption side, rate limiting's super important. And I think the question before as well, having the conditional flows for different customers, that's super important as well. And remember, one of the other things, I don't know if I finished this, but this was quite cool. You've got the developer portal, so you can surface your APIs in the developer portal and have people subscribe to them. But you remember, you've also got the analytics. So say for example, if Charlie logs on and he starts consuming messages out from Kafka, you can understand exactly what that consumer has done, and you could see how much data they've extracted in the last 24 hours and the total active connections they've got. You can even talk about the failed connections and whether and how the upstream broker has what kind of state the upstream broker is as well. So you've got full analytics associated with bringing that data to and from Kafka, if that makes sense. Okay. Yeah, thank you for all the questions. I think they help a lot as well to frame it. It'll be good to just what I'm going to do now is I'm going to actually create an API to Kafka using protocol mediation just to show you the flow. But if you've got any other questions, or it'll be good to understand from your team what kind of use cases you're seeing, around event-driven architecture, and whether you think that any of this functionality kind of would fit into that, like whether it's exposing event-driven architecture as REST, like one for all. Essentially, you kind of consume an API or push an API, and I consume it as REST. Whether you want to have native Kafka to Kafka proxies, or whether you see multiple gateways where people want a single pane of glass to actually see all their APIs and topics in. Anybody see those kind of use cases around?
Sometimes in integration cases we have the following case when some system process the messages asynchronously via messaging. Let it be in this case Kafka, right? And we have input queue or request queue and or topic. Sorry, in case of Kafka, topic, request topic, and reply topic. Yeah, and is it possible via protocol mediation to expose synchronous? I'm talking about request reply for like REST, but under the hood, the gateway, Kafka Gateway will send request message into request topic, wait response, let's say some correlation ID put in header or something else, yeah, and then return as a synchronous. It is not so frequent case, but sometimes we face with such case.
Yeah, that's perfect. So you've actually just basically explained my demo. So let's do that together then. So let me answer that in a demonstrative way. So what we've got here is Gravitee API Gateway. So this time what I'm going to do is I'm going to create a new API, I'm going to call it demo Kafka API. Yeah, and give it a version. This time I'm going to introspect messages from an event backend. Okay, and what I'm going to do is I'm going to post messages. Okay, so I'm going to post messages into Kafka. So let me just paste that into there. I think I've actually got, let me just bring up Confluent Cloud. Yeah, got it there. Okay, so I'm just going to bring up Confluent Cloud in the background. Okay, so demo Kafka API. Okay, and in my backend, there's Kafka. Let me just configure it very quickly. I'm just going to add my Bootstrap server in. So essentially, what I'm doing now is that my backend is a Confluent Cloud cluster. And where I'm getting this data from is cluster settings. I've got like this here, and I've also created API keys. Okay, so just to let you know that this is what I'm going to be writing to in a second. The topic is called general data, and we'll hopefully see that data landing in there. Okay, so I've got my Bootstrap server, and this time I'm going to be a producer of messages. I'm going to use Sassel. I'm going to use plain config, and I'm going to use a config string. Now, I'm adding this as free text, but normally this would be properties or secrets that you can bring in from an external store. Okay, so now I need to add my topic. And if you remember, my topic was called general data. Okay, so let me just check I've done that right. Producer, Sasso, yeah. Okay, that's cool. Okay, so now what I've got is that I've proxied a post onto Kafka. Okay, and I'm pretty sure I called my entry point demo Kafka API. Okay, so now let's go over to here. Let's look at, I've got a Kafka publish here, but I call this demo Kafka. Oops, that's not it. Demo Kafka API. Let me just check out I did that right. Demo Kafka API. Let's just change that to EPAM and do send. Now, if I've done that right, I should get a 202 accepted, which is cool. So now if I head over to my Confluent Cloud window, yeah, there we go. You can actually see EPAM's landed. Can you see that? EPAM, it's very small, so I apologize for that. Let me just do that another couple of times, just change the number. 193, boom. 194, boom. Okay, so now what I've got is that I've answered the first part of that question. You can see 192's arrived, 193. Pretty sure 194 will arrive in a second. Yeah, there we go, 194. So imagine what I've done there, and imagine the simplicity of the methodology of doing it. I've been able to expose just the REST post, just the HTTP post, which is essentially this. If you look at the code, the curl request would be here. And I've been able to push data into a Kafka cluster. Okay, so now I can just say, well, I can basically ask people to post, expose an API in a normal way, but you're mediating essentially the ability to hide the complexity in your backend service. Okay, so now let's look at the consumption part. Okay, so publishing was easy. Now let's look at the consumption. So now I'm going to create another API. So demo Kafka, and this is going on back into the consumer group as well. So demo Kafka, let's do subscribe. Let's call that a good name. Demo Kafka subscribe. Okay, again, same config, not doing anything special, but this time I'm going to be a WebSocket, because when I subscribe to Kafka data, it's not going to be trivial. It's going to be, there's going to be a lot of data coming back. So essentially you want a way of being able to open a channel to see all that data coming through. Okay, so demo Kafka subscribe, just hit there. I'm going to configure my backend again. Let me just check. Okay, so yeah, so this time I am a consumer. I'm going to paste that into there. Use Sassel again. plain I think that's right. So basically, Sasso pub, it's a consumer. Sasso plain that. Offset is latest, but that's configurable. Then general data and keyless again, but you can add authentication if you wanted to. Let me just check that API. I've got a nagging down. I did something wrong there. Okay, I think it looks right. Okay, so now what I've got is I've got a publisher, I've got a post which is sending in messages, and now I've created a WebSocket which is essentially going to take messages out of Kafka as well. Okay, so yeah, let's try that. So if we now go back to here and we go to a WebSocket, so I'm just going to do new request there. Actually, just let me just grab that as well. Just want to grab that string there for new request. Going to paste that into there. Hopefully I've done this right. So demo Kafka subscribe. Now, if I've done that right, this should connect. I think that's right. Okay, so you can see connected here. So essentially, the flow is I've got a post working. I've got a WebSocket which I've opened now. So now let's go back to our post. So here, demo Kafka API. So let's do EPAM 195. At the moment, I think there's 3 messages that have come through, which is actually a good sign because we sent 3 messages earlier. But I just want to show you live. I've posted now 202. There should be a message that's come through. So you can see here, EPAM 195. So if I now go back to that and do 196, it's almost too good to be true, because you can see here, new request, that new request came in 196. So essentially what we've done in that very short period of time is that we've been able to post messages in via REST, get messages out via WebSocket, and therefore you can open up these channels of communication in a super straightforward way. So I've hopefully answered your last question, but in terms of the gentleman that asked the question before, if I now go back to I think you said it on the publish. So if we now go to demo Kafka, let's just get back to that API, this one. So now look at the policies here. So if I add a default flow, you can see here that you've got the normal policies that you can add, but you've now got a second tab, event messages, and here you can add different types of policies. So you can see here that we haven't got a rate limiting on the event messages going in, which is interesting. There is if you did want rate limiting going in, you could do yeah. Okay, so let me come back to that question in a second. But essentially what you can do, one of the policies which is super interesting, is message filtering. So what that means is that if I was getting messages from loads of different places, I could filter those messages to make sure that only certain messages are landing in my Kafka topics as well. So messages from a customer or messages from a partner, you can filter that at this point as well. Okay, so it was a very quick demo, I know, but hopefully I showed you how straightforward it is to proxy protocol mediate messages coming in and out of Kafka. Have you got any questions there?
Thank you. Yes, if you don't mind, just one example from my life. So we have a situation that we need to have a special sequence during processing the message. And this is from one side, from another side, we need to have a parallel flows. So as a result, we was following the pattern that the messages that should be processed sequentially was posted into the same partition. I just want to understand, is it possible to define to which partition your data should go?
Yeah, that's totally correct. So if you now think about messages coming in from post, one thing that you can do is that you can transform the content. So you've got like transform headers, transform query parameters, and also assign attributes. So if you basically want messages to go into the same partition, you can manipulate the messages that's coming in and send and going to Kafka. So remember, you've got a way of mediating the message as it goes through. Now, the problem with mediation is that you're potentially adding to latency. So that's the only problem I see. But you can do it. You can do it.
Good. And based on this description, is my understanding is correct? You allows to add additional headers, because in some cases we are putting headers into the Kafka, and based on these headers, additional filtration is applied.
Yeah. So you can actually remove headers. You can keep headers, and then you can add different headers as well. So you can just do add new header, and you can give it the value, and the value can come from some context parameter essentially, or you can hard code it, do whatever you want.
So potentially I can take headers from HTTP request and put into the Kafka headers, one-to-one mapping.
Perfect. That's exactly right. You can embellish your Kafka messages from headers that are coming in through traditional REST. That's perfect. That's perfect. Yeah. Okay, so I've got a couple of minutes before we kind of I'm going to hand back to Charlie. One thing I did want to talk about, if it's okay, is our Kafka Gateway. So imagine you're kind of talking on the Kafka Gateway. This is a little bit more difficult to see, but essentially what this file is, it's the property file for, actually, let me just crack open my little demo again. This is the demo that I did. Oops, sorry, so many windows. Let me just get that out of the way. So essentially, if you think about this demo, this is basically taking SASL ORF to the gateway and then pushing it to Confluent Cloud. Now, if we look at the property file, which is for the Kafka Gateway, this is exactly defining that flow. So basically what we've got is SASL, which is grabbing a token from an authentication provider. This happens to be Gravitee Access Management. So this is basically this bit of the flow here. Then you've got the end bit of the flow, which is Confluent Cloud. So this is my connection to Confluent Cloud. Don't worry, this is just a demo cluster, so that's why it's open. And then you've got the policies in the middle. So let's talk about these policies. So I'm proxying Kafka to Kafka, Kafka to Kafka, and in the middle, what I've got is the ability to say, okay, I only want this person to read to this topic. I only want this person to have read and write operations on the topic, so they can't create stuff or they can't do anything like that. And also, I only want them to authenticate if they've got a claim inside their JOT token, which has code equals 123. So you can actually configure it right down to the claim level about who has access and who doesn't have access. And this is the ACL policy, essentially. So we've got a policy with ACLs. So you can really configure it right down to that level in terms of how you can manage and use Kafka. Just one final thing I just wanted to show you, which really kind of does bring it home in terms of what Gravitee offers, and it's the developer portal. So now you've got all these APIs, you've got all these topics, you've got APIs coming from different gateways as well. What you can do is that Gravitee actually has a developer portal where you can expose all this, and you can actually, have categories for internal APIs and external APIs. You can add more categories. But essentially what you've got is a really neat way of exposing all your APIs. And you can see that this is the one that we had earlier. We didn't add any docs, but essentially you could subscribe to it. So this is an API that you can subscribe to. one more thing, Charlie. Sorry. I just wanted to show the team one more thing. So these are a couple of examples of people that are Gravitee customers, and they've basically used our base portal and they've customized it. So you can see PostNL, postal service in Holland. You can see here that they've got a really nice, clean, neat developer portal. If I go to technical documentation here, I'm just going to take you to the try it now page. Essentially, if I go back to here, send and track, barcode, generate record, you can see here they've got such a nice little developer portal, but it's based on what Gravitee offers in terms of a management API, and they've been able to kind of create this portal from that. Okay, so definitely I talked too much there. There was a lot to cover, but yeah, thank you for all your questions. And if you've got any more, I'm happy to answer.
Cool. Well done, Nilesh. Thanks very much. And just from me, a very big thank you to Stanislav and your team, and for everybody for having us here today. We've really enjoyed speaking with you all and sort of presenting what we see as big challenges in the industry. Obviously, we're more than happy and pleased, if anything, to connect with you all again if you'd like that. And I'll tell you what, I'll put our contact details and maybe LinkedIn profiles into the chat box as well. So if anybody wanted any more further information or had any more questions that they might not have wanted to ask on this call, then feel free to let us know anytime. We're always available to speak. And thanks again.
Thank you, Charlie, Elish. Guys, if you have questions, just unmute yourself and raise the question without writing down into the chat.
I think one of the most difficult things is to actually show you everything in a 50-minute slot. So if there's anything else that you want to go through or any other demos that you want to see, just let us know and we can jump on a call.
Awesome. So, and maybe one general question, in GitHub we saw the Gravitee repos, and also Gravitee provides some commercial support. It's clear, but from functional perspective, what is the difference between open source, let's say, and commercial one?
Yeah. So essentially, there's elements of Gravitee, including policies, plugins, federation. So there's aspects of Gravitee that are enterprise, and some are kind of open source as well. So we can give you that whole list that separates them. But most importantly, I think for customers, we're offering support and best practice. So we're giving customers that ability to, if you're running an API gateway for your business and you're running it in production, it's best to come to have support with the people that know how to use it best. So I'd say that we've got enterprise functionality and we've got support as well.
Awesome, thank you.
No problem.
Colleagues, any questions?
Not for now, thank you. It was interesting demonstration.
Thank you. Thank you for our speakers. Thank you for our participants for joining. It was really exciting session. Thank you all.
Okay, cheers, guys. Thank you so much.
Thanks for organizing. Appreciate it. Thanks, everyone.